Okay, polar coordinates. It's a different way of graphing, but you can make much more elaborate graphs using polar coordinates. As you can see there, instead of having x and y, where we had two different parts, now we're going to have what's called r, which is radius, and theta, which is angle. See right here we have r and theta instead, because you still really need two directions or two places to go to actually get the point graph. And we are going to start with very simple graphing, just getting some points graphed. Then we'll graph equations. And if you think about it, that's what you did with x and y too. You started just by graphing the points, and then you started graphing equations. And so let's take a look at this particular one. So what is r for this first one we're looking at? R is 3, and theta is 120. I'll be honest, normally it's kind of weird. A lot of times what I do first is actually I find the angle. When we did x and y, we normally did x first, right? But here I normally kind of find the angle first, and that circle right there shouldn't be anything strange to you, but you may notice that it has several circles in there, correct? Instead of just one. We're used to seeing the unit circle, but this one has several. And I could keep going with those circles if I wanted to. I don't have to stop. Yeah. Exactly. That's kind of each circle goes out each radius. And let's say you have a really big graph. You can just say each radius is 10, or you could say each radius is 1, which is normally what we're going to do. So the first thing we have to do here is go to 120 degrees. So you find 120 degrees, which is out there, correct? And what we're going to do is from the center, which is right there, we're going to go out 3 radii. So 1, 2, 3, and that's where the point ends up. And that's all you're graphing today is 1 point.
You said that the circles could keep going.
We could have more circles there, yes.
Well, then is it always going to be 1 between, like from the center out to the farthest end circle?
No, each circle is whatever you want it to be. In this case, we made each circle 1.
That was supposed to be 1.
When we're talking about the unit circle, now we're talking about polar graphing. And it's called polar graphing because if you think about it, if you were looking down at the, say, North Pole, that's kind of what things would look like. Okay, and that is one of the reasons it is called polar. Okay, so obviously that's not the answer right there. That's just me showing you the center. The point is right there, and that's all I got to do. That's 1 point, no big deal. So obviously radians could come into play. Is there anything wrong with changing it to degrees if you're not good at radians? Yeah, there's nothing wrong with that at all. I mean, if you're going to be able to get it right, go for it. 2 pi over 3. Nope, that's 3 pi over 2.
135.
It's 120. Very good. So in other words, we started here, we went to 120, and we went to 3 again. So in other words, I just gave you 2 ways of getting to the same spot. Is that the only way I could have gotten to that spot? No. For example, I could have said, because we could have gone the other way around, right? We could have said negative how much? How far would that be if I made you go that way? Angles can be negative, right? Negative 240. So 3, 240, or negative 240, that would be the same spot, right? So there's a lot of ways to getting to all of these points. Many, many ways you can do it. Okay. So we got 5, 3 pi over 2. So our radius is getting bigger. Could your radius be something like a half? Would that be acceptable as a radius? Sure. If I was doing that, I'd say each circle was a half then, if I was doing that. Just make that note off to the side. But this one here is 3 pi over 2 and 5. Well, where is 3 pi over 2? Again, I like to do the angle first, which is kind of weird. 270. So in other words, we're talking about this general area there. And then from the center, we go out 1, 2, 3, 4, 5, and there it is. Obviously, another one there could have been 5, negative 90. Would have worked, right? Or is another thing? Yes. Oh, okay. What is different? Now, we've talked about negative angles so far, but what's definitely different here? Yes. Negative radius. Do you think you know what we're going to do? Ooh, good idea. I've never thought of that one before. But the problem with going outside in is we don't know how many circles because they can go on forever. But great idea. What you actually do is you flip it over to the other side. So for example, if we went to negative 60, what's a way of saying that for here? Negative 60 is really right here, correct? The positive direction then is from the center out that way. The negative direction is out the other way. So the negative direction, now you got to be careful though, because I kind of missed it. The negative direction is really out, wow, this is really out that way, correct? So for this particular one, this is considered the positive way because that's the angle I told you to go to. So the negative way is shooting out the other way. And so, for example, it'd be right there. It goes out the opposite way of where you were. Okay? So it's just a point. All these lines are just kind of extra. Okay, I'm just trying to show you where everything's coming from. So what I'd like you to do right now is pick one of these 2 points. I really don't care which one. But, let's have maybe half of you choose this point, half of you choose that point, and name it 3 other ways. Get me to the same point, but doing it with 3 different setups. For example, don't use 5, 3 pi over 2, because we already did that one. Now, just being cheap and going 5, 270 degrees, that's pretty cheap. Be a little more creative than that. Okay, so we're going to say that's no good. And same thing here. That's probably no good there. No, I want you to basically graph that point right there or that point right there, whichever one you want to do. But get me to that same point with 3 different ordered pairs. See if you can do it. And I'm going to give you some time for that because this is the first day. Okay. Does anybody believe that either one of them, tell me which one you're going to give me another possibility for? Yes?
For the first one,
Uh-huh.
I have -5, 90.
Okay, she thinks that -5, 90 degrees would be in the same spot.
Yeah.
Do you agree?
Yes.
So if we went to 90 degrees, then went out -5, I agree that is definitely a way that you could do that. Yes? 5, -90. Okay, very good. Does that work? -5, -270.
Yeah, it does. Go to 90 and then go back.
Because you're right here going -270. You'd be up here, correct? And then just go down that way. Okay. Well, 2 positive, yeah, would be the cheap answer for that one, right? Would be the 5 and 270, yeah. Okay, yep. Anybody do this other one? Anybody give it a shot for other answers? Okay. Well, if everybody, I think you get the idea though, right? That you can write it many different ways, using negatives, using positives, many different ways of getting to the same point. This one here, what's different about these? Okay, one just says theta and one just says r, and what did these say back here? They gave you both r and theta, correct? It was just a point. Think back to when we had things, there were times we had x equaling a number and y equaling a number, correct? Those were kind of the so-called specials back when we started graphing lines. X equaling a number was kind of your vertical, y equals the numbers were horizontal. Well, these are kind of specials as well. What you need to do is show me every single ordered pair that could have pi over 3 as its theta. Well, let's find pi over 3 first then. Where would that actually be? Okay, nope. That'd be pi over 6. Yep. So do you agree that that point right there, if I were to graph it or if I were to write the ordered pair, would it have pi over 3 or 60 degrees as its theta? Okay, what if I were to graph, say, that point right there? Even though it's in between one of the circles, is that still going to have 60 degrees or pi over 3 as its angle? Okay, how about this one over here? Could that potentially still have 60 degrees as its angle? It'd be a negative something radius though, wouldn't it? So is that still potentially something that could happen and have that? And so basically it's all of those points, correct? So how are we going to show that? Well, just make a line, yeah. There you go. Once again, these are the specials. Just like x equaling a number and y equaling a number, these are going to be your specials. So am I going to do something very similar for that other one then?
Wait, how do you circle? What do you use for 60? The pi?
Pi over 3. The angle is pi over 3, which is 60 degrees. And so we went to 60 degrees, and I showed you all the points that... Right, for example, if I gave you -5, 60 degrees. Right, that's why I don't have this graph. Exactly. You have it perfect. But you agree this point would be somewhere right over here, right? Yeah. So somebody said just put a circle around it for this other one.
Yeah.
Is that right? So you have to show me all the places where r being 1 would happen. So is r being 1, would that be a possibility?
Yeah.
How about this one over here?
Yeah.
That one over there? And so in other words, as somebody said, well, just make the circle. So in polar coordinates, making a circle is actually pretty easy. And making a line also pretty easy. And some of the more complicated ones, they actually do get somewhat interesting as you go further along. You'll make some flowers and you make
Stars.
some various other things.
Color.